Hello everyone. Today we will be learning about corrosion. Now before we try and define the process of corrosion, let us look at some common examples of corrosion around us. You must have observed the iron gate outside your house rust over a period of time. This reddish brown powder that is formed is hydrated ferric oxide. You must have also observed the silver articles in your house turn black on exposure to the atmosphere. The black compound formed is silver sulfide. Another example for corrosion is the Statue of Liberty. It is mainly made of copper and has a greenish hue. The greenish compound formed on it is copper carbonate, copper hydroxide. Thus, rusting of iron, tarnishing of silver, and patina on copper are all examples of corrosion. Let us now try and define the process of corrosion. It is a slow and natural process in which a refined metal is converted into a most chemically stable form such as oxide, hydroxide, sulfide, etc. by chemical or electrochemical reaction with moisture and other substances in the atmosphere. Now you must be wondering what are the factors that affect the process of corrosion. The first one is the reactivity of metal. More reactive the metal, more prone to corrosion it is. In other words, more electropositive the metal or lower its standard reduction potential, more prone to corrosion it will be. Second, presence of impurities in metal. The presence of impurities hastens the process of corrosion. This is because the impurities disrupt the metallic lattice and air and moisture enters at these strained points to cause corrosion faster. Third, presence of electrolytes. It is found that iron rusts faster in saline water than in fresh water. Fourth, moisture and other substances in the atmosphere. It is found that iron will rust faster in humid coastal areas compared to drier inland areas. Let us now understand the corrosion of iron or rusting of iron in a little more detail. A drop of water on the surface of an iron object will act as a miniature electrochemical cell. One part of the iron object will act as anode and another part will act as cathode. Moisture with dissolved oxygen and carbon dioxide will constitute the electrolyte. At anode, the iron atoms get oxidized. Fe2 plus ions formed get into solution, leaving behind the electrons in the object which are pushed towards the cathodic site. At cathode, the electrons from anode reduce oxygen in the presence of H plus ions to give water. The H plus ions are made available from carbonic acid, which is formed by the dissolution of carbon dioxide in water. When the two half reactions are added together, the net cell reaction is obtained where iron reacts with oxygen and H plus ions to give ferrous ions and water. The standard EMF of this cell is 1.67 volts. Let us now understand how rust is formed. Fe2 plus ions formed come up to the surface where they are further oxidized by oxygen and water to give ferric oxide. Ferric oxide combines with more water molecules to give hydrated ferric oxide, which we commonly call rust. Iron is used extensively. Thus, rusting of iron results in loss of millions around the world. Therefore, it is important for us to understand the methods by which rusting of iron can be prevented. There are three main methods. The first one is barrier protection, second is cathodic protection, and third is alloying. In the first method, which is barrier protection, a barrier is created between the iron object and the atmosphere. This can be achieved by painting, coating the object with oil or grease. Metal powders dissolved in paints is coated onto the metal, or using anti-rust solutions. Alkaline solutions of certain phosphate and chromate salts act as anti-rust solution. For example, iron, when dipped in boiling and strongly alkaline sodium phosphate solution, results in the formation of a protective insoluble layer of iron phosphate. The strongly alkaline solution decreases the availability of H+ ions, which is important in the process of rusting. We can also electroplate the iron object with non-corrosive metals like chromium. We can also carry out galvanization, in which the iron object is coated with zinc. The zinc protects the iron inside by forming zinc carbonate, zinc hydroxide on the surface. The second method is cathodic protection, in which the iron object, like an underground pipe, tank or ship, is connected to a more electropositive metal like magnesium or zinc. The more electropositive metal will act as the anode, where oxidation takes place, and it sacrifices itself in order to protect the cathode, which is the iron object. The third method is alloying. Here, an alloy is a mixture of metals which results in a material with improved properties. Stainless steel is an iron-based alloy where approximately 11% chromium is added in order to prevent corrosion. Let us now summarize what we learned in today's session. We learned how to define corrosion. We also discussed a few examples of corrosion. We looked at some factors that affect the process of corrosion. We learned about the corrosion of iron or rusting of iron in a little more detail. And last but not the least, we discussed a few methods by which corrosion can be prevented. Thank you so much.